So we're going to be beginning our discussion in college algebra with chapter 1, equations and inequalities. So this is section 1.1 in your book, and we'll now go to our objectives. So our learning objectives in this chapter is to solve linear equations in one variable, identify conditional equations, identities, and contradictions, solve rational equations, solve equations for a specified variable. Objective 1, solving linear equations in one variable. So here's our first problem. On the left-hand side of the equation, in the first problem, we have 5 parentheses v minus 4, parentheses closed, minus 2. On the right side of the equation, we have 2 parentheses v plus 7 minus 3. We are solving for v, and so here's our original equation. And now we multiply through, well, we use the distributive property to get 5v minus 20. We leave the minus 2 alone. We also use, on the right side of the equation, we use the distributive property. We get 2v plus 14 minus 3. And now we're going to combine like terms. So in this case, we combine a negative 2 to the negative 20. We get a negative 22. And we leave the 5v alone. We have a 2v. And then on the right side of the equation, we have 14 minus 3 is 11. Now we're going to collect the same terms. So we subtract a minus 2v from both sides of the equation. We get 3v. And we bring the numbers over, since we were going to isolate v on one side. We add 22 to both sides and we get 33. So we divide through by 3 and we get v is equal to 11. And of course you always want to check your work. In this case, you plug that in and you see that indeed we get the right answer. In our second problem, we're seeing that we have a rational expression of linears. And so the first step is to find the common denominator. In this case, the common denominator is 12. And so our first method of solving for y is multiplying both sides of the equation by 12. Again, you will use the distributive property to multiply through by the expressions. When you do that, you get 6 parentheses y plus 5 minus 3 parentheses y minus 2 equals 4 parentheses y plus 7 plus 12. So the next step, of course, is to get rid of the parentheses, and by doing that we use the distributive property. We have 6y plus 30 minus 3y plus 6. On the right hand side of the equation we get 4y plus 28 plus 12, and we are again going to collect like terms. So on the on the left hand side of the equation, we end up with 3y plus 36. On the right side of the equation, we end up with 4y plus 40. And again, when we collect the same terms, or we combine like terms, we move the 40 over to the left hand side. We have a negative 4. And we subtract 3y to both sides and we get y. So this is the final equation, and again we can check the answer, but in checking the answer we will be fine. We get 2 equals 2, and that works. So in this case, the basic ideas of algebra are very important. We're solving linear equations by using the distributive property. We combine like terms, and we isolate the variable that is to be solved. For rational equations, we find the denominator, which we call CD, multiply both sides of the equation by the common denominator, and then solving the rest of the equation, we go up to step 1. So here's an application problem. The cost C in dollars to rent storage unit for T months is given by C equals 150 plus 52.5 times T. If Winston has $1,200 budgeted for storage, for how many months can he rent the unit? Well, here is our original equation, and I put parentheses around T. So in this particular case, we're finding T for cost of $1,200. So we plug in $1,200 for C, right? So we're going to plug it in here, and we're going to solve for T. So when we do that, we subtract 150 from both sides of the equation, and here is our second step. And then we divide by 5250, and we get T is equal to 20 months. So ultimately, Winston has time in the storage unit for about 20 months. Our second objective is to identify conditional equations, identity, and contradictions. So a conditional equation is one where a variable is equal to a number. A contradiction is where both sides of the equation are not equal, and that is definitely a contradiction. And then finally, we end up a situation where 0 equals 0, and we have what's called an identity. So in problem A, we have 4x plus 1 minus x equals 6x minus 2. Again, we combine like terms. We get 3x plus 1 is equal to 6x. And now we have 3 is equal to 3x. Well, how did we get that? That's because we move the 2 over, and we get 3 on one side of the equation, and we bring the 3 over. This should still be minus 2. And we bring the 2 over, we have 3 equals 3x, and we get x is equal to 1, which is a conditional statement. In number B, we did the distributive property. We get a negative 10x minus 2 when we use the distributive property on the left-hand side of the equation for B. And then we were left with 2x minus 12x, which ends up being a negative 10x, plus 6. Well, guess what? The 10x's cancel because if I add both sides of the equation by 10x, they are gone, and we end up with a negative 2 equaling 6. Well, that's a contradiction. They can't equal 6. And in C, again, we use the distributive property. We had 2 times 3x, which is 6x, and we have 2 times a negative 1, which is a negative 2 on the left-hand side of the equation. On the right-hand side of the equation, we have 6x plus 6 minus 8. When we combine like terms on the right-hand side, we get 6x minus 2, which is the same as on the left-hand side, and everything can cancel, and we end up with 0 equals 0. That's an identity. Our next objective is solving rational equations. In this problem, we were looking at the common denominator, y is equal to 3y, and we multiply through by 3y. So we multiply 3y and to the 15 over y, which equals parentheses 21 over 3y plus 2, parentheses close, times 3y. We get the argument of 45 on the left-hand side is equal to 21 plus 6y. Originally, there was a mistake. 21 minus 45 wasn't 33. It ended up being 24. So we do have to check our work. And then we divide both sides by 6, and we get 24 divided by 6 is equal to y. Y is equal to 4, and we check our answer. And you can see that 15 over 4 is equal to 21 over 12 plus 24 over 2. Because of the 2, we changed it into a fraction with the same denominator of 12. And then, of course, we had to change the denominator on the left-hand side of the equation. So we multiplied the top and the bottom of 15 over 4 by 3, and we see that 45 over 12 is equal to 45 over 12. So it checks out. So in this problem, again, you have to find a common denominator. We have three terms. In this case, y is divided by y plus 5 on the left-hand side is equal to a negative 5 divided by y plus 5 plus 5 over 4. So our common denominator is 4 times, parentheses, y plus 5, and we're going to multiply through both sides of the equation by that, and that's what we're doing here. And so you can see that on the left-hand side of the equation we get 4y. On the right-hand side of the equation we get a minus 20 plus 5y plus 25. And then, of course, we have to combine like terms. There are no terms on the left-hand side to combine, but there are on the right-hand side. So we add the 25 to the 20, and we get 5, right? And now we have to combine like terms for both sides of the equation. So we move the 5 over to the left-hand side. We get a negative 5 on that side, and we subtract a 4y from both sides, and so ultimately we get a negative 5 is equal to y. But guess what? If we plug it back into the equation, a negative 5 in the bottom of a denominator, we end up dividing by 0. So we don't have a solution. There's no solution here. Why? Because it's extraneous. We can't do it because a negative 5 will not work in the denominator. Here's another problem that may have a potential problem. So on the left-hand side of the equation, we have 11 divided by x squared plus 5x plus 4 minus 3 divided by x plus 4 is equal to 1 over x plus 1. Our common denominator here is the factors x plus 4 times x plus 1. And we have to multiply through by both sides of the equation. And when we do that, of course, the first term, if we multiply through, guess what? We only end up with 11. If we multiply it through the second term, the x plus 4 goes away, and we have a minus 3 times an x plus 1. On the other side of the equation, the right side of the equation, when we multiply these through, the x plus 1's cancel, and we're left with just x plus 4. And now when we add through the equation, we see immediately on this side of the equation we should still have, and here's where the mistake was, the 4 wasn't considered. So on this side of the equation, a negative 3 plus 11 is 8, but we're still left with a 3x plus 8. And on this side, of course, the 4 isn't there yet, but there's a plus 4. So you have to be careful. Here, this is not the correct answer. So we have to make amends. And when we do that, when we combine like terms, we end up with 4 is equal to 4x. Hopefully you saw that this x here, actually we add through, we add 3x through and we get a 4x on the right hand side, and we subtract 4 from 8 and we end up with 4. Now we divide both sides by 4, and we get 1 is equal to x. Now we should check this thing out, right? So if we do check this out, we get 11 on top, and 1 plus 9 is 10, minus 3 over 5 is equal to 1/2. And so now we have to have the same common denominator through, so 11 over 10 minus 6 over 5, or over 10, sorry, right, is equal to 5 over 10. On the left-hand side, we end up with 5 over 10 is equal to 5 over 10. So it checks out. So there is our solution. So now we're solving equations for a particular variable. So in all these equations, we're just solving for a particular variable. In the first one, it's for t. And so, as you can see, we isolate t on one side of the equation. We divide by PR, and here's our answer. For b, we have a linear equation of two variables. We isolate for y on one side of the equation, and we subtract both sides by a negative 4. And then we want to isolate y continually, so we divide through by 3, and we get the following equation. For c, the first step is going to be multiply through by 2. When we do that, we get 2a is equal to h times big B plus little b. And then we divide by h, so on the left-hand side we get 2a over h is equal to parentheses b plus little b. And since we're solving for little b, we subtract big B from both sides of the equation, and we end up with the following. So one of the tricks of the trade is if we're solving for a variable and the variable happens to be on both sides of the equation, like in practice skill 9, we have to move the variable that we're solving for on the same side of the equation and then move every other variable plus numbers on the other side. So in this case, we started out with the original equation. We moved the AX over to the left-hand side and moved the W over to the right-hand side of the equation, which we can do. And then we used something called the distributive property in reverse, where we took an X out from both terms and we ended up with X times parentheses 3 minus A parentheses closed is equal to W plus Z. Now we divide both sides so we can isolate X on one side of the equation by the expression 3 minus A, and we get the following result. So here's our last problem. It's a word problem. So here Adley's 2012 Mini Cooper gets 37 miles per gallon on the highway and 29 miles per gallon in the city. The amount of gas she uses, A, in gallons, is given by the following equation. A is equal to 1 over 29C plus 1 over 37H, where C is the number of city miles driven and H is the number of highway miles driven. If Adley drove 58 miles in the city and used 5 gallons of gas, how many highway miles did she drive? So we're looking for H in this particular case. So in solving the problem, if she drove 58 miles in the city and used 5 gallons, we now know this is what we're going to start out with, right? A is equal to 5 gallons, C is equal to 58 miles, and H is what we're trying to find. So here's our original equation. And now we're going to solve for H initially. So to solve for H, we move the 1 over 29C to the left-hand side of the equation. And then we multiply through by 37, and we end up with H is equal to this particular equation. Now that we have this, we're going to, in the parentheses, use the common denominator. So we get something that looks like this, 37 times parentheses 29A minus C all over 29. And then we just plug the numbers in. We plug 5 in for A, 58 for C, and we just do our calculation, and we see we get 111 miles that is traveled on the highway. Well, that concludes our chapter 1.1. Please look at the lecture notes for class, and we'll be trying to solve some problems in class.